It's a really big one. Okay. These are the beginning of your notes. Today is the 13th.
I'm so tired.
Please make sure we're getting this heading written down so that we can get started. So this is going to be. Thank you.
Oh yeah, we're already at 1.4.
This is 1.5 actually.
What?
Hey,
No, 1.4 was the exponents. Mm-hmm.
This is so sad.
Make sure you get these written down. Okay, when you are doing Cornell notes over this, the essential question is now at the top.
Do we write the question?
Yes, because you'll need it on your Cornell notes.
Oh, okay.
So we write that every time.
It's really annoying. There's like 20 of them.
Just under the squiggly line.
I'm really tired. Dimensions. Oh.
I released in 2 days. No, it's better. We'll be a team.
Right.
I also do this.
What
Maybe I just wanted to say. Even if it means for like us to go like an hour. Good. We're gonna
All right, guys, we're going to go ahead and get started. So we are talking about square roots. Specifically, we're going to talk about a lot of perfect squares today. The state of Oklahoma wishes that you are able to identify perfect squares all the way up to 400. Okay. Which so the 400 being a perfect square, what is the square root of 400? It's a good guess.
What is that?
Don't divide it by 2, because when we think of squares, we're thinking of 4 sides. But what? There's a lot of side conversations going on, guys. It's okay. Okay. So the state of Oklahoma wishes that you can recognize perfect squares up to 400. Okay. 400, the square root of 400 would be 20. 20 times 20 is 400. Okay. So you would need to be able to recognize what 2 times 2 is, 3 times 3, 4 times 4, all the way up to 20 times 20 is what they would hope. Okay? So the symbol for squaring a number, okay, is the exponent 2. Do we all agree with this? Okay. What is 4 squared? So 4 squared is 4 times 4. Okay, so it is 16. Okay, now part of where calling it a square does literally come from the area of a square. Okay, now what are the characteristics of a square?
They're all equal.
Okay, 4 sides and they're all equal to each other. Okay, so when you are finding the area of a square, you are just squaring one of the sides, right? So this table over here. Okay, if we're finding the area of that, that's going to move over eventually. We'll call that a square. It really looks more like a rhombus, but we'll call it a square. Okay, so actually it looks more like a trapezoid. Anyway, if the side length, okay, we'll say is 1 meter. Okay, what is the area of this square?
The area?
Mm-hmm.
Are you recording, Mr. Bennett?
Do what? Yes, I am.
Mr. Bennett, what's that after squaring a, what does it say?
So, when we are finding the area, you are doing length times width. Now, when we are working with a square, we can almost just say it's one of the sides squared. Okay? So, what is 1 squared? Just 1. Okay? Now, if we change this measurement to 2, what would the area of that square be? Four. And what are we doing to the 2? 2 times 2.
Yes.
Okay. So if we have the length of 3, now guys, you'll start to recognize the pattern. Okay. So if we have a side that is 3 meters long, what is the area of that square? 9. Don't put 6. Okay. If it's 4, 16. Okay, and lastly, for the purposes of this table, if it's 5, 25. Okay. What is the pattern? That every single one of these side lengths, which we might call x, is being squared. Okay? Yeah, so you are taking whatever that base number is, in this instance we'll say x, and multiplying it by itself. Okay? So, length times width. So I'm saying for a square, you can almost do a equals a side, so s squared. Yep. Okay. So if the exponent of 2 is the symbol for squaring something, what is the symbol for doing the inverse of that? What is the symbol for doing the inverse of squaring? What is the inverse of squaring? Actually, technically, yes, it is. But we don't look at it like that. We call it the square root. Okay, and what does the square root look like? Yeah, right there. We call it a radical. So, discuss with the person you're sitting closest to for the next 30 seconds, and please keep the conversation related to algebra. What do we think the square root of 16 would be? 30 seconds, go. Make sure you can explain why.
Yeah.
Yes. Now, obviously.
What is that sound?
It sounds like somebody's cutting into concrete to me. Maybe on the street. It's our new detention wing.
No, we didn't. Yeah, we never. It's just dumb. It doesn't teach us how to be better.
It just puts us.
You think I'm gonna learn how to be better?
Okay, so I heard it a bunch. Okay, what's the square root of 16? 4. Okay, so let's keep moving. Let's say that I have a square.
Wow, that's a perfect square. Did you draw that? Did you do that?
Yeah, I just punched that out.
Wow, this is the most perfect square.
Yeah, I know. I'm
You're a
I've-
professional.
hidden talents. Okay, so let's try this one. The area of this square is 121 square feet. I wrote that terribly. My apologies. Area equals 121 feet squared. Okay. Tell me what S is. Tell me what S is. The area is 100. Here, I'll put.
It's 11.
Oh my. I just erased it. Now y'all are going to see my secret.
Is it 11?
Okay, the area is 121.
Is it 11?
Smart.
Okay, so we just worked backwards from this when talking about the radical. Okay, so when we are doing the square root, we can think of it as we have the area already. We need to find the sides. Okay, so you are looking for a base number that you can multiply to itself to get 121. Okay, so this is called trial and error. Okay, which is a literal method in algebra. Okay, you just try stuff till it works. What's 10 times 10?
100.
Okay. Yeah, so 10 times 10 is 100. Okay, so if we just go up from there and we try 11, 11 times 11 is 121. So start using some reference points. Okay, we're pretty comfortable with 100. Okay, it's a number that we're used to. Okay, so use those reference points to help you guess. Okay, so the sides would equal 11. Okay, let's do another one. Oh no. Yes.
It's the same square.
Okay, so let's say that the area is 4/9 feet squared. The area is 4/9 feet squared. take 1 minute to figure out what S would be. So this is working backwards from the exponent stuff you just did. Okay? Feet squared. 4/9 feet squared. Feet squared means feet is the unit of measurement we're using. Squared means that it is the area of this square. Okay, so it's covering the inside of the square. The reason we use that, and the only reason we use that little 2 is it's basically labeling it, just so that you know. It doesn't have any numerical value.
Is it a fraction or
The answer should be a fraction.
Okay.
Which one?
Let's find out.
Okay. Who thinks they got it? You went the other direction. So this is already the area, Joey. So we don't want to square this. We want to take the square root of this.
Like when they ask for the area, and I'm like, I don't know how to do this.
Nice. That makes me feel really, really excited.
Yeah, so I'll remember this. Yeah, I'll remember this. Actually, get this now.
Good. Okay, let's come together. Who thinks they got it? Yeah, go for it. There we go. Okay, so we have 4/9. If we are taking the square root, focus please. We are taking the square root. You can kind of take the square root of both of those individually. Okay, so what is the square root of 4? 2. 2 times 2 equals 4. Do we agree? Okay, what's the square root of 9? 3. 3 times 3 equals 9. So 2/3 would be S, not 5. S. Okay? Let's keep going.
Oh, that's easy. Okay, this is so fun. I'm having so much fun.
All right, so find the square roots of these practice problems right here. It is a negative sign. It is a plus minus.
What is plus minus?
You will find out. Yep.
I was supposed to answer both.
Yep. Did I drop out? I'm not allowed to teach. I mean, technically, I could drop out and get my GED and then still go to college. So that's actually not accurate. You what? No, I did. I was just saying. I had to have a bachelor's degree to work here. So. And I'm in school right now. So.
Let's see. Why is there like a plus and a negative? Why did you do that? Oh my god.
Just answer both.
Okay. Yeah. See, I'm smart. Exactly. We're black. No. Do you just put the square root in the answer?
Do what? 4 is a bachelor's degree. You thought it was how many? 2 is an associate's degree. Should be under there. Yeah. You should.
I don't know why this is as a hobby because it's such a small book and I think it's really dumb.
It's because of money.
But it's dumb. I'm gonna read the book.
The books are really good. So you took the square root, so your solution, your answer. Yep. It's not difficult. You feel like it should be way harder, Katie? All right, let's check ourselves. 4A. Again, just trial and error, okay? We recognize 25. We're pretty used to that number. Okay, what is the square root of 25? Okay. Letter B is pretty similar to the square that we had right above it. Okay, we've got this big fraction with a negative out in front. The negative needs to stay out in front. It's not affected by the radical at all. Technically, you can take the square root of a negative number, but that will get us into imaginary numbers, and we're not going to be dealing with imaginary numbers. So it's true. The square root. So here, if I take the square root of -4, technically the answer is 2i.
Wait, what? What is that?
It's some. We're not learning that. We're not learning that this year.
We're learning that next year?
That is algebra 2, I believe.
What is algebra 2?
Do what?
When's algebra 2?
Junior year math.
Junior. We're gonna learn that next year. People in this.
No, you'll do algebra 1 next year.
Okay. And how many math classes do you like at this?
Here, 3.
So you teach
Pre-algebra, algebra 1, and geometry.
Is geometry algebra 2 or no?
Geometry is before algebra 2.
So it's like
Sophomore.
Oh my god! Everyone here is so smart.
Including you.
Yeah, but I'm just a little bit smarter than you.
All right, let's come together. 3, 2. Okay. Yeah, D. Yeah. Katie, what'd you get for B? -3/4. Okay. So again, when you're looking at this, you want to take the square root of each individual number. Okay. You can take the square root of 9 and the square root of 16. Okay. And I'll just pause that until I get done. Thank you. Okay. Now, if you are just really struggling with how to even start this, okay, I would like to show you prime factorization. Okay. Now, prime factorization will work. It'll work on problems like A and B. Okay. It'll be more difficult to use it on something like C. Something like C is where I would say use your calculator. Okay. But let's look at. I want to show you. So here, this is something important for you to make note of. Okay. So I'm about to show you prime factorization. Okay, so with prime factorization, let's say we use the number 16. Okay, so we're trying just the bottom part of letter B. Okay. What is a prime number? Does anybody know? Okay, so a prime number are numbers that can only be divided by itself or 1. Okay, so prime numbers would be 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay, all of those numbers are prime numbers. Now, I've already said this sentence, so let's see if y'all are going to piss me off or not.
Oh no.
Okay? Because I've already said this answer. What is a prime number? How do you define it?
It's something that can't be.
It's something that only, yeah.
Or what?
Or by one.
Or by one. Okay. So, non-prime numbers or composite numbers can be divided by more than just themselves in one. 2 is not a prime number, or is a prime number, right? But what about 4? 4 can be divided by 4 and 1, but also 2. So if you ever have an and also, it's not a prime number. What about 6? Yeah, not a prime number because 3. Okay. 9. No. 10. 11.
Yes.
Yeah, good. Okay, 12.
No.
11 is a prime number.
Oh.
Yes, because it can only be divided by itself in 1. 13.
No.
Is it a prime number or not? Yes, it is. Okay. 14.
No.
15.
No.
It's all right. Don't be too fast with our answers. 16.
No.
No. Okay. 17. Yeah, I'll stop there. Okay. We kind of get the idea. Okay. So when we're doing prime factorization, please follow this. Please follow this. Okay. You're going to take your base number. So in this instance, I'm just using 16. Let's say I have no idea how to start finding the square root of 16. I'm going to use a little upside down divisor bar. And I'm going to start dividing the number inside by prime numbers. Okay? But I'm only going to use prime numbers that will divide evenly. Okay, so only give me integers. What are integers? No? We'll have to go over a real number system then. Integers are positive and negative whole numbers. Okay? So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, all of those are integers. Okay? So, what can I divide 16 by evenly? It's got to be a prime number. Prime number. 2. Okay? What is 16 divided by 2? 8. Then we do it again. What is a prime number you can divide 8 by? Prime number. 2. Okay, that gives us 4. What's a prime number we can divide 4 by? 2. And then lastly, what is a prime number we can divide 2 by? 1 or 2, right? So I'm always going to work this all the way down to a 1. Okay? You work it all the way down to a 1, then you're done with that part, D. Nope. It's a good question. Okay? We'll do another example where it won't be that way. So now what you do, because we are working with square roots, okay? Square is talking about how many exponents? 2. Okay? So we are looking for groups of 2. So you're going to pair them up. Okay, once you pair them up, they now become one single version of that number. So this is A2. This is A2. Okay? So now we have prime factorized. Okay? We have grouped up any pairs that we see. Now our last step is to put these back together with multiplication. What's 2 times 2? 4. 4 is the square root of 16. Do we all agree? Okay, so that is how you use prime factorization. Do we want to try a different one? I think we should. Let's do one where we already know the answer. What's the square root of 36? 6. Okay. Now, if you don't know that off the top of your head, here's how you do it without a calculator. What is a prime number you can divide 36 by? 2. 36 divided by 2 is 18. What's a prime number you can divide 18 by? 2, which gives you 9. Finish the rest of this by only dividing by prime numbers and see how you do. Because 9 won't divide by 2. You got to pick a different number.
What are the prime numbers?
1, 2, 3, 5, 7, 11.
9.
Plus. Okay, what's a prime number you can divide 9 by? 3. That gives you 3. What's a prime number you can divide 3 by? 3. Okay, we're down to a 1. Does that mean you're done with the factorization part? Yes, it does. Okay, now what's your next step? You're going to group. Okay, group them up. Like an extra? I will show you. Yeah, we'll get there. Okay, so we have a group of 2s. What else do we have a pair of? I have a pair of 3s. So again, when you pair them up, they become one number. And then what do you do at the end? Put them back together. What's 2 times 3? 6. We said at the beginning, what's the square root of 36? 6. It works every time. Okay? So let's pick a number where it doesn't come out pretty. Let's do the square root of 50. Okay, the square root of 50. So, what do we know what the square root of 50 is? It is not 25. 25 times 25 is a much larger number than 50. Y'all just divided it by 2. So the answer is no. We don't know what the square root of 50 is because it doesn't come out evenly, right? If we're going prime numbers or perfect squares, we know that 36 is, the square root of 36 is 6. What's the square root of 49? 7. What's the square root of 64?
8.
Okay, so it's somewhere in between there, right? The square root of 49 and square root of 64 is somewhere in between there, okay? But we can figure out exactly what it is. So what's a prime number we can divide 50 by? 2. 25. What's a prime number you can divide 25 by? 25 is not the answer. But we couldn't divide by 25 because it's not a prime number. What's a prime number we can divide 25 by? Yeah, 5. And that gives us 5. What's a prime number we can divide 5 by? 5. That gets us down to 1. Now what do we do? Okay, so we have one pair of 5s. Jay, I haven't posted this video yet, so you can close that. So once we find the pair of 5s, what do we do with them? Yep. Now what do we see that's different from the previous 2 that we did? Yeah, we don't have a pair of 2s. Okay, so here is the kind of exception, and this is why the square root of 50 is not something we just knew off the top of our head. Okay, we have 5 right here. There's nothing to combine it with, so we just bring it down. Okay, then because we don't have anything to group the 2's with, the 2 has to go back inside the radical. So the technical answer is 5 square roots of 2. Okay, now if I punched into my calculator 5 times the square root of 2, and I don't have it in math print. And I square that, it will give me 50. Okay. Here, let me show you. Oh, plenty of time. Okay, so let me show you what this looks like. So, quiet please. Quiet please. Okay, so on the calculator, okay, if we take 5 square roots of 2, come on, there we go. Okay, close those parentheses, and then we want to square it. What should our answer be? 50. Okay, so it still comes out, works out. Okay, the actual answer, okay, what two whole numbers is 5 square roots of 2 going to be in between? Yeah, so that's this is a fun question, and this is one you're actually going to be tested over. So if I gave you the problem, oh my. Okay, so let's say I give you square roots of 50 again. Okay, but what I'm asking for is what two integers, okay, which are whole numbers, positive or negative, what two integers does the square root of 50 fall in between? Okay, now we kind of already talked through this. Okay, we said we know what the square root of 49 is. It's what? 7. And what's the square root of 64? So what two integers is it between? 7 and 8. Okay, so if we go back to the calculator, okay, and we just punch in 5 square roots of 2, and we hit enter, it's 7.07, which falls right in between 7 and 8. Okay, we'll do some more work on that particular question. So the answer would be that it falls between 7 and 8. Okay, let's look at, so we did some prime factorization. I want to go back to those 3 problems that we were just doing so that we can talk about the last 2, okay? So we did B, never mind, just the last one. Okay, so if we look at letter C, okay, it's plus or minus the square root of 2.25. Now, hopefully we used our calculator. Did we find out what the square root of 2.25 is? Yeah, it's 1.5, okay? So it'll come out to be 1.5. Okay. Now with the plus or minus out front, how does that affect your answer? In this particular case, it is both. So it is a positive and a negative answer. Okay. So if you ever see the plus minus sign, the plus minus means that there's going to be a positive version and a negative version of your answer. Okay. And the plus minus will make a lot more sense when you get into quadratic formula stuff. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, thank you.
I learned it in 8th grade. Yep. And there's a song that goes with it, and y'all are going to learn it, and then we're going to walk around the school and sing it.
No, we're not.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Wow, you're such a good person.
I won't forget about y'all when I'm famous, I promise. Okay, so. I know. What's it got, like 50 views? Not even. It's got like 30. Oh, okay. All right. So let's keep going. So we're going to go on to a kind of a separate section. So this is evaluating expressions with square roots. So evaluating expressions with square roots. Let's say we have letter A, and letter A is 5 times the square root of 36 plus 7. I would like for you and the person you're sitting close to try and simplify that. Do I need to do one with you?
No.
I think we can
Try.
try.
That's my son's favorite thing right now. When I tell him no, he will say, "Will you try?" Because he doesn't understand that effort is not the reason I'm telling him no, that he can't have ice cream.
Why even try to answer it?
Why even show my work?
Okay, for those of you that felt like letter A was too easy,
Yeah, it was like oh, this one's going to be so easy. I'm just going to be so small. I'm just going to watch this. Oh, wait. Okay.
not right now.
Yeah, you try.
Yeah, will you try?
When he thinks we like he's saying this or like
Yeah, so he'll be like, "Can we go swimming?" And I'm just like, "No, but we can't right now. It's too cold." And he'll be like, "Can we try?"
like try to swim.
It's like, do what? In the sink? He's a little too big. He's a little too big for a bath in the sink.
I used to get back to this.
Oh yeah, it's like the easiest way to give a bath for a little
I
one.
used to like.
Do what?
I don't know. I never asked my parents if they gave me that.
For real little babies, we had this like waterproof seat that had a strap on it, so we just stick them on there in the sink and then use the sprayer. Yeah, that was a long time ago though.
That one was a little too easy.
Letter B.
Yeah. I know.
All right.
On the grind every day.
Oh wait.
All right, so let's talk about A and B, and then we'll go on to letter C, which is a little different. So, order of operations are very important. What are your order of operations?
Parentheses, exponent, multiplication, division, addition, subtraction.
Oh.
I just helped my cousin with his homework the other day.
Nice. So that means your first step is which one? Parentheses. Do we see any parentheses?
No.
Okay. What about the exponents?
No. Oh, wait. Huh?
Exponents,
What are we talking about?
exponents, and radicals go in the same group. Okay. So we've got to take care of the square root of 36. So what is the square root of 36? 6. So that gives us 5 times 6 plus 7. What's 5 times 6? 30 plus 7 equals 37. Okay. 1/4 plus the square root of 18 over 2. Okay. So what is the really important first step on this one? Yeah, we need to simplify that fraction. So when you have a radical, okay, on letter A, focus for me, guys. I'm talking over a lot of people. On letter A, you didn't have anything inside the radical to simplify. It was just 36, okay? But on letter B, we have a fraction of 18 over 2. We do not want to take the square root of 18 and the square root of 2 and try and put that together, okay? So you want to try and simplify it if you can. We can simplify it. So I'm going to rewrite it as 1/4 plus what's the square root of, what's 18 over 2? Yeah, so I'll just say 9. Okay, now what's the square root of 9? 3. Okay, so what is your answer? Okay, if you put 3 and 1/4, I would prefer no mixed fractions. Okay, but if you put, so technically this is the same answer and correct. Okay, technically this is the same answer and correct. This is the most preferred answer, is what I would say. Good. It's all right. All right, letter C. Yes. Letter C, we have the square root of 81 squared minus 5. It's
Hey, what was that?
that was yesterday. That? Yeah. It's an interview yesterday. No, it was at the Bricktown ballpark. We're pretty famous. I don't know. That's just where they did the show. All right. So let's look at letter C. All right. Let's come together. Let's come together. Okay. So what's our first step? Yes. So inside the parentheses, what do we need to reduce? Yeah, the radical. What is the square root of 81? Okay, now what do we need to do? The exponent. What's 9 squared? Okay, so this little trick. Listen, please, because I can show you a way that will make your work go quicker. This only will apply for those of you that this makes sense right off the bat. Okay, if it doesn't make sense to you right off the bat, and I'm talking about this, what I'm about to show you. So what I'm about to show you is a shortcut. Okay, if it doesn't make sense to you, don't worry about it. Okay, because it will eventually down the road. Okay, if it does make sense to you right now, then you should utilize it. Okay, so if we're just looking at this problem, okay, so I've got the square root of 81 in parentheses, and then I'm squaring it minus 5. Okay, we have talked a little bit about doing inverse operations or undoing operations when we were solving equations. Okay, so what's the opposite of multiplying? Dividing. Okay, and or what's the opposite of subtracting? Right, and when you wanted to cancel something out, you would zero it out by doing the exact opposite operation, right? Okay, so we're taking the square root of 81. What's the opposite of taking the square root of 81? Squaring 81. So these are inverse operations of each other, so the exponent right here actually makes the radical cancel out, and you can just bring down the 81 minus 5. Yes.
Well, you did it before.
Yes.
Yeah, it's like the beginning.
Agreed.
Makes so much sense.
Wait, so
Yep.
if it has a, how do you know when to do it? If it has an exponent?
So if you have a radical on the inside and then it's being squared, you're just going to end up undoing what you just did. So they'll cancel out. All right.
Yeah, we did that last year.
Let's do who wants a real life application problem?
Application for what?
Probably all of you.
But this lesson is so long.
What am I applying?
Well, it's not that long, but we spent the first 30 minutes or so going over the homework and stuff. So,
Did you make this?
what do you mean?
Like all this?
All this material? No, I'm just teaching it.
You made.
Some of the stuff I make, but today I did not because it's already made. So,
Who decided to just like they were just like it like how did that prove that like it can be wrong. Why did like make it 8? You like what make it 5?
I don't know. I'll ask Google. See what I find. Okay, real life application. So let's say the area of a crop circle is 45,216 square feet. You do not have to write out the whole problem, but I will put a star next to it so you can make sure what you're referencing. Okay, so what is the radius of the crop circle? Okay, use 3.14 or I'm going to have to put it in pi. Okay, so the area equals pi r squared, okay, of a circle. Okay, so the area of this circle is 45,216 square feet. Okay, so you need to find out what the radius is. We're going to fill in this formula right here. A equals pi r squared with the information that we already know. So what is the area? What's the area? 45,216 equals pi r squared. Okay, so this goes back to solving equations. What's our variable? What's the variable? What's the unknown? R. Yep, it's R. Okay, so how do we get R by itself? First, you had a problem like this on your notes from last time. Not the exponents notes, but the solving equations notes. How do we get R by itself? We're gonna have to move some stuff, right? What do we need to move? We do need to move the exponent and we need to move the pi. Yep, both of them. So we're gonna move the pi first because it's being multiplied. What's the inverse operation of multiplying by pi? dividing by pi. Okay, so right now would be a great time for you to get your calculator out. Okay, punch in 45,216 and divide it by. Divide by pi. Look up in the original problem, the wording. What does it say? Use what for pi? 3.14. I mean, it's a never-ending number. Maybe. Maybe not. Okay. So what do we get? What's 45,216 divided by pi? Just one person. 14,400. That's it? 14,400? Okay. Equals r squared. Now how do we get the rest of this? Yeah. And how do we do that? What's the inverse operation of squaring something? Yeah, square rooting. So we are going to take the square root of both sides. Okay, so this is just like that problem that we just looked at, right? We have r squared. We're trying to get it down to just r. So the inverse operation of squaring it is taking the square root. Okay, so the 2 and the radical are going to cancel out. Just give us r. And somebody with a calculator, tell me what the square root of 14,400 is.
Oh, I don't know how to say that. It's
120.
120. Okay. I need to make some more Cornell note copies. You will have a notebook check on Thursday. These notes do not need to be done by then. Okay. But please make sure that you have your exponent notes and these notes in your notebook. Okay. These Cornell notes can be due next week sometime. I'll put a more specific date on it on Thursday.